Right. All right, let's see how quick I can get through this with you. There are 6 sections to the notes, and this again is all based on the complaints, if you will. So in step 1, in section 1, oh, by the way, today is 131, right? I should maybe add that up here. Today is 131:23. Tomorrow is the first day of February, which is pretty cool. And today we will be evaluating harder logarithms. I mean, I kind of want to put harder in quotes because it's like once you know what you're doing, they're really not all that much harder. Nice. So in section 1 of the notes, we're going to talk about something that has absolutely nothing to do with logarithms at all. In section 1, we're going to be converting exponential expressions into radical expressions and vice versa. It'll make perfect sense here in about 2 minutes and 12 seconds, mark my words. So first things first, say we had x to the power of 3/4. Being your algebra teacher, I feel like I'm safe to say you probably haven't done too much with this. You might have seen it in Mr. Manlove's 8th grade class, and we might have just dabbled a little bit in our Algebra 1, but really that should mean very little to you. So do you guys know how to convert this into a radical, like a root by chance? The exponent is a fraction, and fractions have 2 parts, the top and the bottom. And so each part of the fraction has a job to do. So the first number that I want to bring your attention to is the number 4. And he says, you're going to make me a root, but we're going to call it a 4th root. So the bottom of the fractional exponent dictates what we call the index of the root. And then the top of the fractional exponent, the 3, becomes a power, and then the x just goes inside like this. It's very, very literal. Like there's not a lot of debate or up in the air kind of. It's like you put this here, boom. The only thing that will change in the future is you see this yellow 3. There will come a point when we're encouraged or allowed to put it outside. But for today's work that we do, you're going to continuously be seeing it or putting it inside. So just be advised, though, that power part, the top of the fraction, can go inside on the thing or completely outside the root. You pick. But I say today you're going to pick the inside. Any questions about that? How about this one? X to the 5/2. And you just have to know who everybody's job is, like what everybody's job is. That's it. It's the square root of x to the 5th. Notice that we don't see the number 2. Why is that? Because it's a square root, and we don't put 2's on square roots because everybody knows that it's a second root when we don't put a number there. Okay? How about this one? How about x to the 1/3? What would that be? Yeah, the cube root of x. And again, there's a number that you don't see, and we're far enough along in our math careers that you understand why we don't see it. Normal math people generally don't put x to the 1th. So is everybody at ease, kind of at peace with how the fraction becomes that radical thing, like where each number goes? Let's do it backwards. So on the other side of this curtain, I'm going to give you some problems, but we're going to work the same process, only backwards. So let's say I gave you the cube root of x to the 10th. What is that?
X.
Very good. X to the 10/3. Everybody has a job and they know exactly what it is. That top, the power says I go here. The index number on the radical says I go here. And they all high five and move on their way. How about the 4th root of e to the 7th? What would that be? E to the 7/4.
Would you ever give it this one where you'd have to simplify it?
There's going to be a ton of simplifying today. So this is very much just our little warm up. Will someone shut the door, please? I keep forgetting to do that preemptively. Thank you. As I was preparing my notes, I hesitated on this one because I figured that you guys were going to tell me that the answer is 1,000 to the 1/5. But I was going to have to say no. So there's a little bit of a trick here. And I'm going to tell you what the answer is, and then you can maybe help me construct, like, why would anyone do that? It'll make a lot more sense in about 20 minutes why we do this. But the answer is 10 to the 3/5.
Well, keep it at 10.
10 cubed is 1,000. Yes, good. There's a real strong reason for playing with numbers like this. If I give you 100 today, you better start thinking of it as 10 squared. If I give you 1,000,000, you better start thinking of it as 10 to the 6th. If I give you 10,000, you better think of it as 10 to the 4th, et cetera, et cetera. Powers of 10 play a huge role in this lesson. So what happened was inside the radical, I took the number 1,000 and I thought of it as 10 to the power of 3. And again, that's going to work well when we play with logarithms today that have a base of 10. So that's why that one went the way it did. Is everybody comfortable with kind of section 1 there? Okay. Let's head on to the second section. In the second section, what we're doing is we're being introduced to two new sort of types of logarithms. They are called common and natural logarithms. They're the two most frequently seen / used types of logarithms in math. And I'll try to explain to you why that is. May not be the best explanation. But first off, let's talk about this word common. The common log is any log that has a base of 10. And to make it even worse, you won't see the base of 10. I'm not really gonna, I'm not a big vocab guy, so I'm not gonna like pop quiz you on a quiz like to define something for me, but it helps us to communicate if you know what a common log is. A log with a base of 10, the 10 is invisible. And so from this point on, if someone gives you a common log, it might look like this. And if you've been in class and been working, you should ask a very intelligent question and say, where's the base? But what I'm trying to say is if there's not one there, it's a 10. That's called a common log. What is log of 100 then? It is 2. Because remember, the basics of logarithms, if I give you log base 10, you're really just looking for what exponent do I have to put on that 10 to turn it into 100? 2. How about this one? What's log of 100,000? It is 5. What's log of 10? It is 1. So from this point on in this lesson and for the rest of your academic career, understand that if someone gives you a log, L-O-G, without a base, there is a base, it's 10. It's called a common logarithm. Got it? The other type of logarithm that we're going to talk about today is a natural log. And I should switch colors for this because if you got the colors, why not use them? So for a natural log, that is a log with a base of the number e. Tomorrow in class, we'll watch a short video. I'm going to go home tonight and pick the very best YouTube video I can find, giving you some insight as to where the number e comes from. I don't want to clumsily try to explain it right now because it won't end well. But like pi, pi isn't something that someone made. Pi is something that naturally happens. If you go home tonight and take anything circular in your house and measure it very carefully, called the circumference, right? And then divide by the distance right down the middle, that's called the diameter. Do you know what you get if you divide this one by this one, right? You always get pi. So pi, it's like up there. It's like no one invented pi. Pi is a number that naturally exists. And the same can be said for our new buddy, e. E is a number, and it's somewhere in the ballpark of like 2.71828 ... If you ever want to know what it is, we could just type E on our calculator, hit enter, and it'll tell you right what it is. But like pi, it goes on forever. So anyways, a natural logarithm is a log with a base of e. And you will hardly ever see it written as log base e. You will, however, see it written as ln. And again, from this moment right now until the day you decide to stop using or taking math classes, your job now is to know that ln stands for natural log, and it is a log with a base of e. So having said that, if I gave you the natural log of e squared, anybody know what it is? Every time you see, follow my yellow boxes up here if you'd be so kind. I can see now why second hour wanted me to talk more about this. Your stunned silence tells me I let them down. Every time you see this, that stands for natural log, you should replace it with this. Not necessarily on paper, but in your mind. So when you see the problem that I wrote down, the natural log of e squared, you really ought to write it, at least until you get good at this, as log base e of e squared. ln stands for natural log, and it is a log with a base of e. Now, when you see it like that, does the answer just pop right out? What is log base e of e squared? Of course it's 2. Of course it's 2. Because, I mean, think about the ridiculous nature of what I just asked you. I literally just asked you, I'm going to write this in green. I seriously, right here, just asked you e to what power equals e squared. Are you freaking kidding me? It's like a trick question. So yes, of course it's 2. Good. Let's go again. Natural log of e to the 10th. What is it? It is 10. It's so hilariously redundant. It's like, are you kidding me? You're just asking me to basically copy down the exponent from one side. Yeah, right? How about the natural log of e? We're still in, we're getting there. It's 1. Very good. So at this point, I have checked 2 things off my list of things to talk about. Where are you at right now? Are you okay? Okay. Let's head on to section 3. In section 3, this was a big one. This is one where they got on me pretty bad earlier and said, you need to talk more about this. And this is my bad because I thought that these were in your log assignments that I'd been giving you on Delta. They're not. And I dropped the ball there too. So do you guys remember how like this is true? If you were in class when we learned this about a week and a half ago, you know that this is true. You'll remember that things that have negative exponents, they don't become negative numbers. They just get moved to the bottom of a fraction, right? Is that ringing any bells? So like 5 to the negative third is 1 over 125. Are we all okay with that? Okay. So having said that, let me start then the third section of our notes and see how this goes for you. So I'm going to put up a problem. Yes, it would be 1/6. Yeah, I just didn't ever finish it, but yeah, totally. Sorry about that. So here comes a log problem for you. I want you guys to help me with log base 4 of 1/4. Again, if you're good at translations, then you understand, okay, here's what my math teacher is asking me, and I'm going to write this in big obnoxious red. He's asking me, so 4, oops, I didn't get to switch to red. He's asking me 4 to what power equals 1/4. That's all this logarithmic sort of relationship ever has been, is this to the this equals this over and over again. What power would I have to raise 4 up to get him to turn into 1/4? -1. Very good. I know it's going to be a negative answer because I'm forcing that logarithm base, the 4, I'm forcing him into the basement. And the only way to make that happen is with a negative log or a negative power. How about this one? Again, if you're wanting to ask the question, where's the base? You're still in your learning, and I get that. But is there a base? Yes, it's 10. You just can't see it. Remember, this is our first example of sort of a common log in the wild. There it is. So there's a log with a base of 10. One thing's for dang sure, I know my answer is going to be negative. How many tens do I need in the bottom to make the 1,000? I need 3. So my answer is negative 3. How about this one? Natural log of 1 over e. It's definitely negative something, but it is negative 1. Because remember that ln is a natural log. And what that really said, I'm going to erase this here, is it really said log base e. And so if you think about it, what power do I have to raise e to make it become 1 over e? Just the negative 1 will suffice. Aiden, does that make sense? Okay. Let me switch colors here so you can see where I'm writing. How about this one? How about log base 2 of 1/64th? Nice job. It is negative. Now, I know one thing, like when I'm working with kids who are learning how to add and subtract, if I say what's 5 minus 8, even if they really struggle, I like it when they say negative while they work out the fact that it's negative 3. You know what I mean by that? Like if I said, what's 10 minus 54? I like it when a kid goes, okay, it's negative. It's like, good, good, good. So when you come into this, at least like maybe get the negative part out of the way and then backtrack to find the power that you need. How about this one? I'll switch colors again. It's not the same problem, right? This time it's negative, but it's only negative 3. So as that base of the logarithm changes, so too does my expectation of the exponent. I don't need 6 2's like I did on the last one. I only need 3 4's. And if this were your classroom and you were going to write yet another version of this problem involving the number 64, you could take it even another step and say log base 8 of 1/64th. And you're like, oh, still negative, but I only need 2 8's to make a 64. Okay. I think I covered my page of notes on this. Does that section feel okay? These negative answers, they should stick out like a sore thumb. You see them coming because you're like, the argument of the log is the dead giveaway. Fraction, 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 fraction. Those yellow boxes up there should be all you need to say, I'm looking for a negative power, right? In section 4, this would be, I don't think I've been labeling them, but this technically is like the 4th section of my notes. And so um, we're going to start evaluating logs that have radicals in them. So I have 3 I had to, I get so ahead of myself. I had to force myself to write really easy ones for this section. So for our first example, I want us to do log base 8 of the 5th root of 8. And the first part of today's lesson should, within about 30 seconds, you're going to go, oh, so that's why he taught me that. It'll become very obvious. What I want you to do is either thumb back or look up in your notes and riddle me this. How could I write what's in this yellow box using exponents instead of radicals? Nice job, Lane. So I could rewrite this actually as log base 8 of 8 to the 1/5 power. Nice job. That's an expert conversion because now, I hope, the answer is obvious. What is log base 8 of 8 to the 1/5? In other words, let me say this again. 8 to what power? That's this right here. Equals 8 to the 1/5. Yes. Nice. It is easy. And once that light bulb flips on, as is often the case, it is very easy. Until the light bulb comes on, it is really confusing. But watch out for this. I'm going to highlight a couple things in green for you. And I want you to know as we go through the rest of this lesson, this is ridiculously important. This base matches this base, and that's huge. If the base of your log and the base of the argument of the log match up, then it becomes a redundancy issue. Whatever the exponent is, it's what you need. Done. Easy. Let's try again. Log base 4 of the cube root of 4. I teach math the way I would want to be taught by using colors and examples. So I'm telling you again, that gold box is critical. Go back to the beginning of the lesson. How can I rewrite or re-understand what the cube root of 4 really means? What does it really say? Log base 4 of 4 to the 1/3. I can convert a radical into an exponent. And once I do that, I'm like, there it is again, redundancy. The base of the log, the base of the argument, they match. What is the answer? 1/3. Still good? Okay. How about this one? How about log base x of the 5th root of x cubed? I mean, you look at a problem like this 20 minutes ago and you're like, what is he talking about? But now you're like, wait, I got a tool for this. I know what to do. I know that anytime this gold box can be rewritten as an exponent guy, that's what my teacher's saying I should do. I'm going to do that. So I'm going to write this now as log base x of x to what power? To the 3/5. So what is the answer to the problem? 3/5. If you can get those bases to match, you're golden. Everybody still okay? Okay. Next section. I call this section 5 on my note cards. We're going to be doing exactly what we did in section 4, but this time the bases are not going to be the same. So for our first example, watch out. We have log base 4 of the cube root of 16. It's hard to listen. I know all day, every day, listen to your teachers drone on. But you heard me say something about how important it is to match the bases. And last I checked, don't you can write this down, but know that we're not doing anything good right now. I could, if I just do it like the last example, I could write it as log base 4 of 16 to the 1/3. But I want to draw your attention to something. This is not the same as this. So for that reason, let's go for a different plan of attack. Yes. Yes. So what's going to happen is this. We're going to take this number on the inside of the radical, and we're going to ask ourselves a question. Can we write it as a power where it also has a base of 4? And the answer is yeah. I could rewrite this problem like this. Log base 4 of the cube root of, wait for it, 4 squared. Dope. Look at that. And just like that, operation match the bases has been completed. And I hope by this point in the lesson, it becomes obvious that the answer is 2/3. Let's go again. This is, I thought, kind of the hardest part of the lecture today. So when we have to start playing with the bases, it can get a little tricky. So let's do log base 3 of the 5th root of 81. So again, 81 in its current form is of no use to me, bless you. But 81 can be written as a power of 3. What is 81? Say it again. Yes. And if you were to ask a question like, how do you know that? Or why do you know that? My answer is You just need to keep practicing. Use your resources, but try to start thinking about doing more of those 3 to the 4th, 3 to the 5th, 2 to the 5th, 4 to the 3rd. The more of that you start to commit into your head, the quicker you're going to be. But then I did it. Operation make the bases the same is complete. What is the answer to this problem? It is 4/5. Now, I'm going to write another problem, and I tried to kind of make this point earlier today that might feel the same to you, but it's a substantially different sort of thing. This time we're going to do log base 9 of the 5th root of 81. 81 is just like a punching bag. 81 sits there and he's like, okay, you do what you got to do. So, like in the last problem, we said to 81, we want you to be 3 to the 4th. What do we want 81 to be in this problem? Yes, we want him to be 9 squared because operation match the base. So we want log base 9 of the 5th root of 9 squared. What is the answer to this one? Yes. How about this one? Log base 5 of the square root of 125. Operation match the base. Yes, the answer is 3/2. I got to think about the 125 and say, I know who you are. You walk around here telling everyone your name is 125, but I know that you're actually 5 to the 3rd. And I like that because operation match the base is complete. And then the answer is 3/2. How about log base 8 of the 7th root of 512? Use your resources here. You know, 8 cubed is exactly 512. Very good. Good job using your resources back there. I see you doing that, and I appreciate that. So this is actually log base 8 of the 7th root of 8 cubed. The answer just falls right off the page. What is it? Nice job. That concludes the next to last part. This part I'm adding in because I got not really yelled at, but I got told my business earlier. A few people actually said, we need to see more of this. So the last part of my notes are dedicated just to problems where you can't see the base. So they gave me a few really big talkings to, this was one of them. So here we go. Let's practice logarithm problems where you can't see the base, AKA common logs and natural logs. So say I gave you like log of the cube root of 100. What is the base? It is 10. So if you feel like it, listen, there is no law. Look what I'm going to do in red. There is no federal law prohibiting you from writing in a base of 10. You get down with your base right and bad self. That's fine. So now operation match the base says, what do we want to do with the number 100? We want to think of it as 10 squared. So it's log base 10 of the cube root of 10 squared. The answer is 2/3. How about this one? The natural log of the 4th root of e. Say, I can't hear you whispering at me a lot today. What? It is 1/4. Very good. And the reason for that, in case you're wondering where that came from, is remember, anytime you see ln, you're welcome to write it as log base e. I don't, but you're welcome to. And so once I acknowledge that ln, natural log, and log base e are the same, and then if I rewrite the 4th root of e as e to the 1/4, it's again just hilariously obvious where the answer comes from. You guys feel like you're doing okay? Okay, good. Couple more, I suppose. Let's do the natural log of the 11th root of e to the 4th. What's the answer? Good job, 4/11. How about the log of 1 over Um, 10. Very good. You start answering questions that quickly, that means that we're together as a team doing something right. So that's good. I could just keep going, but my spidey sense is telling me that I think you're okay now. Everybody feel okay? You understand when you're going to use negative exponents. You understand that if you see log, the base is 10. If you see ln, the base is e. Beyond that, I'd be happy to answer questions. Your assignment is on Delta Math. It should take you no longer than 10 minutes or so, something like that.
Make these documents.
Sure.
I have